Welcome to this paper 1 topic, travel graphs. So we have two subheadings in this topic. The first one is distance time graph. The second one is speed time graph. We're going to start with distance time graph. Then when we get done, we're going to take a look at speed time graph. So whenever you are dealing with this type of question, make sure you know if it is a distance time graph or a speed time graph, as the interpretation is a bit different. So like I said, there are two types, a distance time graph and a speed time graph. So a distance time graph is going to have distance either in kilometers or meters or centimeters on the y-axis, and time in seconds or sometimes hours or minutes on the x-axis. So take care of what is here and what is here. Each graph is read or is named by starting with the parameter that is on the y-axis, then you go to the parameter that is on the x-axis. So in case you have been given a graph and want to know what type of graph it is, look at your y, then look at your x. So this is a distance time graph. Distance time graph. So we're going to analyze the major parts of any distance time graph. But there's this formula that's going to be cardinal in dealing with this graph, and this is speed is equal to distance over time. On top is distance, which is the y-axis, and on the bottom is time, which is the x-axis. So actually maybe there's only one formula on distance time graph. It's going to be based on this, but it's going to be just changed in a way. So the units of speed are meters per second. If there's kilometer here, there's going to be kilometers per second. If there is hour here, then on the part of S, there will be HR, which is hour. So this is a simple distance time graph. So it has three main parts. So the first part is this part. So here, these two lines are just showing us where the first part of the journey ends. The journey starts here. So you should be able to visualize what's happening here. So we have a movement. It can be someone who is about to move. So at here, the distance is 0 and the time is 0. So we get a stopwatch. We start it as the journey starts. So as the person progresses, we're going to be recording the time, and that time is what we're going to put on the time axis, and the distance they're covering is going to be put on the distance axis. So if the graph is going like this, it means there is an increase in distance with time. So when it reaches here, you can see that this person has covered 80 meters in 10 seconds, or this, if it's a car, it has covered 80 meters, 80 kilometers in this case, in 10 seconds. So this part represents increasing distance with time. So increasing distance with time, or change in distance with time, is what we call as speed. So here there is speed. So if it is drawn like this, it means the speed is uniform. Then the second part is BC. From here to here, we have drawn another line. So here between B and C, this part we don't have any movement. Why? Because time is moving, but there's no change in distance. It can be maybe if we're recording or monitoring your movement, it can be maybe you have met someone, then you're talking to that person. Or maybe if you went to buy something, we can assume this is the time you're buying, because time is moving, but distance is not moving. You're not increasing the distance or reducing the distance. So here, there's no speed. Speed is 0. Then the last part of the journey is CD. So during this part CD, we can see that time, of course, is still increasing, but distance is reducing. Okay, So mean that this person is going back to where they come from, where they came from. So in summary, the parts are, this first part represents uniform speed. What it means by uniform speed, it means the speed here is the same as the speed here, is the same as the speed here, is the same as the speed here. So if you know the speed here, then you should assume that it is the same speed here. So the speed is uniform. Then here there is zero speed or no movement. So when for example, if I ask you what is the speed at 30 seconds, so at 30 seconds it's here. If you go up here, you are going to reach this point, and at this point there is no increase in speed with time. So there's no increase in distance with time, mean that speed is 0, but distance is still 80 kilometers and time is of course 30. The last part is of course it has uniform speed, but it represents the returning journey. Okay, but what is important is it has uniform speed, just like here. Here the speed was increasing, but here we can say the speed is reducing because distance is reducing as time proceeds, though it is okay. Let's take it like that. We can see that time is increasing but distance is reducing. So if distance is reducing and time is still increasing at the same rate, then we can say it is the speed is reducing. But what you should take from here is this part has uniform speed, and the same as this part, uniform speed, zero speed. So these are the most important parts of this graph. So now in a case where, let's say, I want to find this uniform speed, how do we get it? Here we know it's 0, but how do we get the uniform speed here and here? So we use this formula, but it is a bit modified. So instead of saying speed is equal to distance over time, we say speed is change in distance over change in time. Okay, so we get distance at 2 points, maybe here and here, which is 80 and 0, and we get the time at these 2 points, the same point and the same point, meaning 10 and 0. Then we divide them. So in short, this is the formula for speed: final distance minus initial distance over final time minus initial time. So let's take a look at an example. So in the distance time graph on the left, find the speed between AB. They want us to find the speed between AB. Distance covered at time 2 seconds. The distance that was covered at time 2 seconds. 2 seconds somewhere here. They want us to know the distance that these 2 seconds, which we are not sure where exactly it is. They want to know how much this distance was covered at this unknown 2 seconds, but we know it's somewhere here. So mean that we're going to use what we know about this area, the uniform speed. Then also they want the speed at 30 seconds, the speed at 30 seconds here, so this should be easy. So we're going to start with speed between AB. Speed between AB. So what do we need? Remember our formula. Speed is final distance minus initial distance, final time minus initial time. So I can choose any 2 points between AB. This formula is the same as gradient. Remember, when we are finding gradient in coordinate geometry, we say x2 minus x1, y2 minus y1 over x2 minus x1. It's the same, so it's the same kind of thinking. You just need 2 points and their coordinates, then you get the y values and the x values. So in this case, I'll choose point A and point B. Point B is 10,80 and point A is 0,0. Okay, meaning that our final distance is 80 and our initial distance is 0. Our final time is 10, our initial time is 0. So when we plug in here and when we divide, we're going to get the speed as 8 kilometers per second. So here I deliberately wrote meters per second to emphasize that it's not always meters per second. When it's written like this, it's wrong if we have been given kilometers, but most will be given meters. But if we have been given kilometers, here it should be kilometers per second, unless they have specified that. Write your answer in meters per second, mean that these kilometers to be changed to meters. Question B, distance covered at time 2 seconds. So from now onwards, we're going to be assuming that this is meters. So the K will forget about it so that everything is balanced. So distance covered at time 2 seconds. So 2 seconds is somewhere here. Okay, so 2 seconds is here. So they want the distance here. We are just guessing, we don't know where 2 seconds is, but we know that it is between 0 and 10, so it's somewhere here. So if we go up, assuming, then the distance should also be between 0 and 40 here. So whatever we're going to get, it should be between 0 and 40. We're just guessing anyway. So, but how can we find the distance? So there's something we know about this. The speed is uniform, which implies that the speed here is the same as the speed here, is the same as the speed here, is the same as the speed here, and it's the same as the speed here. So wherever the 2 seconds is, that's where wherever the 2 seconds is, the speed is the same as the speed we calculated in the previous question. So we're going to do this. We're going to act as if we want to find the speed at 2 seconds. Since we know it, but we're going to act as if we want to find the speed at 2 seconds. So we're going to say speed is equal to final distance minus initial distance, final time minus initial time. Speed, we are going to put that which we calculated in the previous question. Final distance is the one we're looking for. Initial distance, we're going to start from here, so it's 0. Final time is the 2 seconds they've given us. Initial time, here where we're starting from, it's 0. So we're going to have this. So df minus 0 is df, 2 minus 0 is 2. So we can do cross multiply. When you do cross multiply, it's going to be 2 times 8, 16 meters as the final distance, which of course represents the distance covered at time 2 seconds. The last question is speed at 30 seconds. So if we go at 30 seconds, which is here, so what's the speed here? Here, there is no movement. Because of this, there is no movement, there is 0 speed. So the speed is 0. Well, this marks the end of part 1 of our travel graphs. Watch out for part 2, which is going to be centered on speed time graphs. Happy solving!